Good afternoon, everybody. We welcome Andrew Lee from Taiwan. He will tell us how to run your own Debian distro based on containers. Welcome.
Hello, everyone. Thank you for attending my talk. This talk is about, I will share my experience that I've been using the infrastructure in my work. And we use this to build the Debian-based distributions. And during the talk, I will share the features about this infrastructure has. And also, I show you guys how to set it up. And also, I will share about how to optimize this to the whole infrastructure that we are using. Okay, and this infrastructure is just based on the open source open build service. I make the Debian package for that on the stretch release. And this is a very nice tool that can save lots of time on and resource for teamwork. So let me introduce myself. My name is Li Jianqiu, or you can call me Andrew Lee. I'm from Taiwan. I've become Debian developer since 2009, like 10 years ago. I was in the DebConf in Spain, in Extremadura. I became Debian developer during that time. And for the beginning, I joined Debian, I already maintained the LXDE packages. So I started packaging like 2005, 2006, and I will co-work with lots of other Debian developers. And since that they feel tired to upload my packages, so they asked me to become the Debian maintainer, and then eventually I become a DD. Okay, and for my work, I work in the Collabora in the build and infrastructure team for more than 6 years, and have been working with the OBS, Open Build Service packages, for internal projects. I build lots of things for our customer, and here is the time I'm sharing that how nice this tool is. Okay, let's give you an overview about how do we do. And before we start to that, we look at what's the classic infrastructure we use. Like without the OBS, we have to build the package for our customer. For example, we need to have a clean root. Here is an example. We use a clean root for stretch. We build the package, and then we publish the package in the repository, so that the customer or user can get the package directly from the repository. If you have more and more user, then you probably user has more requests. Then you build maybe the package, same package with different distributions. So here example that you have Debian stretch and also Debian buster. So, and then in this time you have a need to maintain 2 clean routers for building those packages. And then for the time being, of course you get more requests. Maybe they request other architectures, not only the MD64, maybe the ARM. So the same source, but you need to maintain multiple rooters and also on different architectures to support, to build the binary packages and then put it into the repository. And just imagine that how many rooters you have to maintain. Like here example that the user requested that not only the software on the Debian, they also want to support on Ubuntu. Then you need more builds, and just see that how, if you increase that request from the user, then you can see that image how many different rooters you have to maintain to build the package all the time, and then you have to publish the binary into the repository for user to download. This is a mess. So the OBS is designed for solving this kind of mess. So the infrastructure on container I want to show you is like you can put, however, choose your own distributions, because I put the OBS package into the Docker container. So in my choice, I choose Debian as a cloud distributors, and then I can put Docker inside, and then I fetch the image. So that all the infrastructure is very easy to set up on the cloud, and then you can start to use the infrastructure. And the mix will be solved, because everything, the tutor, you don't have to maintain yourself. Everything is maintained by the OBS, the building functions. So let's look at the benefit of the OBS. So here you can see that the OBS has a built-in feature. It automatically bootstrap a clean root all the time. So here you can see the example. He bootstrapped on the architecture ND64, and he pulled in all this kind of thing. So in OBS, you just need to do the source upload. They automatically build with consistently and also reproducible way. So you don't have to worry about those machine or root sometimes get changed or something anymore, because everything is on the server on the cloud. So even your team, you have different people doing the development. You upload, then you build on the guarantee that's built on the same clean root. Unlike that, you build some root on your machine, and maybe your colleague has another version of a root, then maybe you have a considerable problem. But here is no problem at all. And also, you don't kill the battery time on your laptop. You don't have to build locally. You just upload, and they build on the server. So here is an example. You can see we have only one source package. And doing the configuration, you can see that they build multiple architectures and also different distributions. You can see the example that the Debian JC and also Ubuntu in different version. You can see that also the architectures on ND64 and also the architectures. So this is very nice. And it's not only just automatically can build and also publish the routines. It's not only. It also has a built-in very nice workflow. Just imagine that you have some product is in the production, and you want to have some new update. But before the update, you should better have some QA to do test, right? So in the OBS, you can submit those kind of things for the review, so the QA can do the test on the real hardware or something before publish it to the production. And after that, you build these things, you publish, it automatically generated the repository for you. So it's very nice handling tool. And then for users, because that published to those kind of repository, so user can easily to get a notice about the new package update arrive with the apt tools. Okay, and then it also has a built-in nice feature like a VCS-like version control. It's building on the web front end. So every time you do some new update, you track all the source update. Then you can see that the change logs, everything are different revision. You can see the history on the web UI. So if something goes wrong, you can also revert the previous source update. So you can override. So it's a very nice tool. If you found something you publish and then something doesn't work, you can revert easily. And you can rework on also the QA, internal test. And also, every time you do the source upload, you don't have to worry about the build dependencies, because that have built-in features that will automatically calculate what kind of build dependency it needs. And then he will schedule the source package and the binary package, and then do the build. So you can see here is an example that how many number of packages that the build failed, missing. See that in the status. So it's easy to get an overview of all the packages in your distributions about the status. And sometimes we get several packages that failed, and then we are the team, so everybody can choose different kind of package to get to fix the fail to build from source issue separately. So you can speed up the process to build, so no one is getting blocked for the other one. So you can go through this process really easy. Here example that if you click on the user interface, they will show you what is the missing build dependency or something. That maybe something is new, it's not imported, then you should import it to the directory. And then it will fit the missing build dependencies and will start to unblock the build. Okay, this is the building access control list. So on the OBS, you can configure it that as different project, and different project maybe has different team, different members to work on different projects. So you can have the permission control, who has a right access, who can submit, who can do review. So everything is there. You can customize different project, different team to work on. And you can also hide the project without the team member cannot see. So it's a great feature. And after we talk about all his benefit and the nice features, so now we can look at how to set it up. So what do you need? You just need your own distro, is anyone you like, and then you have to have the .io package and also .composer installed. And then you can fetch the OBS Docker images on the Git repository. And then once you check out the repository, there is a README Markdown file. You can read it, how to generate the containers images. And just follow that. After you generate all the images on your machine, then you can use a Docker Composer app to bring out all the containers. And then besides that, you also need to configure the DNS for your container. And here, the example, we use the OBS-API for the example. You can change and you can update that yourself on your setup. So because this is very simple, and I think that it's not long enough time in my talk, so yeah, please allow me to skip the installation demo. So let's look at that after you installed. If you follow the document, you will get a web UI like this. And then here, I said that this DNS configuration, you need to update the DNS. And then you just, for this example, I put the OBS-API, and I can see this HTTPS interface on the HTTPS. So you can see that there's a login, and also you can sign on the new account there. Here, the default installation, the default username and password I didn't change. If you want to use that in the production, please change that, update that. And also, I not recommend you run this in the public environment because the security support are limited because the upstream doesn't want to support the version of the different gens are running. Because in Debian, we have a different set of Ruby gens to run on this web UI, which totally completely different set of the gens are using by the upstream, OBS upstream. So I recommend use this internally for internal project, not access for the public. If you want to use the public, please consider install the upstream one from the open source. Okay, and then we go down, and the default username and password is the username is admin, the A is uppercase, and then password is open source. And once you log in, then you can see the admin account in this page, and then you can go back to the command line. Okay. This is the login to the administrator page, and you can create a configuration the projects on this page, and also can configure the OBS. And here is the example that show you the Docker OBS Git repository you previously checked out. So we already wrote a configuration shell script to help you to do the setup and do the testing. Because most of the time I realized when after people install the OBS package, they do not really know how to configure the project correctly. So I got lots of email and asked those kind of things. So we decided to make a shell script, so very easy. So here example that you just follow this shell script, they automatically configure project and also submit the hello package to build, to test the environment. So here you go. So when you do this, you need to go to the OBS test directory. And in that directory, you can find the shell script called the test DOD_1. The DOD means download on demand. Just imagine that you want to build those packages, right? And then all the package has to build dependencies. If you have the project based on Debian Stretch or Debian Buster, you just imagine that you don't want to have a local mirror of loss on the server, right? So that's the DoD. For DoD is automatically fetch those missing build dependencies on demand. So when you do the source upload, the DoD will do the calculation for how many, what kind of build dependency is required, and then you will pull automatically in the background from the mirror you configured in the web UI. And then you post those build dependency and then start to the build. After the build, it will publish. So here is a script. You do that, then you can run the script. The syntax is that the script name and also the front-end host. So here is the example we use, OBS-API for the example host name. So the script is cute and give you the such a result. And then after this, then you go back to the web UI. Oops. So once you got the result, you switch back to the web browser and reload your patch. Then you can see that there's a package and the project get created. You see that on the circle there. There's a Debian DoD got created and also the hello package uploaded. Then you can click on the hello package. Then you can see that the build status. You can see that all the build status are currently blocked because there was the DoD is working in the background to fetch all the build dependencies. Then you see that it's, click on that, they will see that how many packages that's working need to fetch in the background. And meanwhile, after it fetch all the build dependency packages, it will start to the build. Then you can see that multiple different childs are working parallelly during your configuration. So you can see that it builds some architecture has been building, some is successful, some still waiting. It depends on how many build nodes you have. Okay, let's talk about the infrastructure components. The whole OBS is not just one package. It's actually its whole infrastructure, including the server side to storage all the packages, and also the worker. OBS worker is the building node. You can add more nodes in the cloud. So you have multiple nodes. That means that you can build how many packages parallelly in the same time. And also the web front end is only one that requires the SQLDB, and that's called the OBS API, which is a Ruby on Rails app. So only this one. And then also have the command line tools. The command line tools are OSC package and also OSC dput plugin. Okay, let's look at the OSC command and see that how those kind of thing works with OBS. So for the first time user, that OSC will prompt for this configuration. So when you do that, it will ask you for the username and the password and so on, maybe also the self-signed certificate if you want to trust that or something. So here just an example that with the user use the admin account, then you can, or if you have your own, you create your own account, you can also use that in the web UI from here. Okay, this example use admin and use the default password, for example. And then you will ask that self-signed certificate. Then you do the self-signed certificate. After that, you can start to use this. So, for instance, that we use OSC, and CO means checkout. We check out the test repository was created by the DoD script previously we have. So he checked out the hello package, right? What's built in there. And you see that we check out the hello package, and then we go inside the folder, and then we use ls command. We see, oh, the source package is there, check out already. And now we can start to do our modification on the source package. We extract that first, and then we go into that package directory and start to work on something. And then, of course, after we work on that, we need I think I lost some slide here. Okay. Oh, so just, for example, we just provide some patch inside the folder, and we do some update. Then we need to regenerate the new package. Yeah, and to modify your Debian package, you require some Debian packaging skill. So if you haven't done that yet, I recommend you can read the maintainer guide to understand the files on the Debian folder and do the update. So after that, we do the patch. For example, now we need to update the changelog entries. So here, example that we modify the hello package. So we wanted to do a test. So we modify, and I use a new revision plus A1, for example. So after that, we save the changelog, and we just rebuild the source package. We don't need to build a binary. We just build a source package. So it's a dpkg build package -- uppercase ace command to build. And -d, it means that it skipped the build dependencies. You just need to generate the source package. And then after that, you can see the source package generated by this way with the new revision. And then we go to the folder and see the files. Then you can see that originally the hello package is there, and also this new source package I generated for the test. Okay, and then we use the OSC command to, we need to drop all the old version and add the new one. So use that OSC AR. It will remove the old one and add the new one. And then we do OSC commit. And then also -m is that commit message. Now you can see that it deleted the old version and then do the new upload into the OBS server on the cloud. And this one, then you can check the progress. We go back to the web front end. Then you can see that the new version upload there, and then also the build status. So you see that they are built on both Debian JC and the stretch on AMD64. And if you click on the succeed green link, then you can see the build result like this. And if you see that something failed, also you click on the link, you can see the fail to build from source messages. Okay, and I will go next command. This is a OSC dput plugin. It provides similar like a Debian dput syntax to upload the package with the OSC command. So here is an example. Let's get a source package for the maintainer guide, for example here. And then after we fetch the source package, we can use ls command to see the source package files. Of course, that we use that OSC dput test. The test is the project you have on the OBS configuration, and then you put the DSC file in the end, and then with this, it will do the upload. Again, we check the progress after we run the command. Then we go to the web front end on OBS, and in the front page, always you can see the latest update, the recent update packages there. So if you click on that, then you can see of course, the build status. And then, of course, this is a new upload, and maybe the build dependency is not local cached on the server, so the DoD will start working and processing the build. Okay, this is what we are using OBS and have this kind of functions. And now I want to share about how do we optimize this infrastructure at work. Okay. Those are the tools I will mention that we integrate with OBS. And the first is merge our MISC. This one is we were forked from the Ubuntu's merge automatic package. So we can do the automatically continuous package integration. So this script will look at the upstream package version and compare with the local one. And then if that the one with applies our data on that works, so it will automatically merge it and then submit the package into OBS. So as the maintainer, we can see the new package arrives on the OBS project and the request for approval or not. So you have QA can do a test before, and then sometimes the package is merged, is a three-way merge failed, or somehow it succeeded, but he uploaded, but failed to build from source. And only those we need the human resource to look at, but mostly will be automatically. So here you can see that the submit from the merge automatic user, automatic submission, the continuously integration. And also you can somehow modify the OBS source code to add the hook with your bug tracker to update the status. So maybe the package build or package learned into repository. So some tasks need to be updated on the bug tracker. For example, here is we did the patch to modify that. So every time when we publish the new package into the production repository, the bug tracker will be triggered update. And also, you can also integrate with Jenkins to build your package directly from Git. So here is an example that it's a Jenkins job that builds a new Linux package from Git. Excuse me. And here that he fetched the package and then extract the source and also fetched all the patches from the Git and start the build, and also the script in Jenkins just rebuild the source package, appended with a new revision, like here, and also run the OSCAR command, like the workflow I showed you before. So he submit a new version into the OBS, and then we just wait for the result on the OBS. So we don't have to try it on a local machine. Okay, and then you can also use Jenkins to build distro images from Git. So here example that the Jenkins job will get triggered by the GitLab to build the distribution image automatically. So he fetched the repository and start to do the build. You can also do this, and then the image script will need to have a local archive to fetch that all your packages build the image, right? And the archive will be provided by the OBS, so you can build directly with Jenkins and also OBS. And also you can integrate this with Lava to do the automatic test on the real hardware. Lava is a tool from Linaro, which is an automatic validation system on the real hardware. And Lava is behind the Kernel CI, so which is a project to automatic test and verify kernel boot. So integrate with Lava, and you can boot the image I showed you generated previously, and the boots on the real hardware to run the automatic test. So which is very nice. You can run your image before, automatically before you really have a user to run on the real machines. Okay, there are more optimizations, and there's another talk about this, about Git and OBS from Andrew Shadula, and also in this talk room on 5 p.m. today. And my colleague Andrew Shadula will cover more about the optimization, about how to maintain and build the whole distributions with OBS and based on Git. So let's recap. So during my talk, I think that you already see that how the benefit that using OBS, you can save a lot of time and resource in the team. And the team can use OBS infrastructure to work together very easily. And also manage that the package to be landed in production repository or not. So it's very tiny tools. And remember that you can see that in this infrastructure may benefit you, and also you learned that it's easy to get the OBS Docker image to set it up, and then some possibilities to how to optimize and integrate such infrastructure into your current infrastructures for your own project. So my talk is end up here. I want to thank for everybody who was involved. And there are so many people many people. Without those people, I couldn't make the OBS as Debian package. And you may not use Debian upstream directly to build a Debian-based distribution easily. So thank you for listening, and then any questions?
Hi, I have two questions, if I may. One is testing. Can you prevent publication of all packages if the build failed for one architecture, or if it failed for a particular target, like Debian Stretch, but work for Buster and so on? And the other question, you mentioned at some point that you can revert. And I didn't get that quite well. Can you revert it after it was published? So, and if that's the case, what do you do with users who have that package already installed?
Okay, usually the revert is not on the published. If it's published, that when you do a revert, that means more human involved, because like, for instance, the package is the newer version already published on the archive, right? And then you revert on the OBS. That means that all the revision, you have to remove. Yeah, you have to go to the repository to fix that yourself. But I think the revert is good for the internal test. You do something experimental, it's not good, so you can revert back to, so still have the QA have some working version. So because that, you can see that OBS has different branch to work. So you can see that the QA, they submitted the request, it was from another branch and want to merge into the production branch. So the QA can have a multiple branch to this, so the revert I think is better to do it on the separate branch, not the production one.
I also have like two use cases where I wasted a lot of time previously while building packages or ISO images for a distribution. One of the things is you mentioned that you can build packages on multiple different CH roots, or let's say for Jesse, Stretch, or Buster. Could we have, like, all these CH roots are pre-configured, or could you configure a few CH roots to have custom repository URLs and stuff?
I think this all flexibly can configure in the OBS project. We also have some use case that we build one source package for both Debian format and also RPM. So you just need to provide those kind of things, and the project you can configure what kind of target distribution you want to build, and also what kind of architectures. And then you need to provide the DOD URL. So when the OBS want to build, he knows how to bootstrap clean chute from which URL, and then start to pull all the missing build dependencies.
Okay. The next question is, you mentioned building packages. Those packages, and you mentioned that it also provides those packages with a repository. So the endpoint URLs of those repositories, and let's say if for some packages I want a development repository and then a final repository to be used by the end users or the customer. So is these custom repositories and stuff all possible on the OBS side?
I think that in the published part, you can also look at the OBS code. So the example I showed on my talk, we hook with the other tool in Debian, so to generate the format of the archive. But in the default, I think OBS uses flat repository. You need to configure that, and then you want to have something for the internal. Okay, yes, we do have some URL for the internal QA script to run. And then of course that for production will be another URL. So you can configure those for the publish part. It's very easy, and then you can look at the code, it's very simple.
Thank you.
Welcome.
Further questions? So, thank you very much.
Okay. Thank you.